The universe is calling me. It speaks both day and night. It's full of dark and light. And I've heard others call from light years away, and they're real and they're here. Space and time are instantly clear. Planets spin, grids in place. We can travel through space, fields and forms, math and voids. It all sings with one voice. It's boundaries set, foundations laid. Sound was heard, matter made. Solar systems from afar. Names and numbers for the stars. And I've heard others call from light years away, and they're real and they're here. Space and time are instantly clear. Planets spin, grids in place. We can travel through space. It's the Lord's.
Hey folks, welcome to SkyTour Livestream. It is I, Mark D'Antonio, here with you, and we have a special guest tonight, and that would be Bill Skywatcher. Bill, what's happening?
What's up, Mark? How are you tonight?
I'm fine. We have an early crew who's joined us out there. We have Elise or Alice. We have Eliza Raquel. Hi there. How are you? Daryl's taking the night off. He's a little under the weather. So we have Bill Skywatcher with us. Bill Skywatcher is also the famous guy who is the biggest producer over at KGRA Radio, our alma mater when it comes to where we started. We started life with KGRA Radio, and we still have SkyTour Radio on Sunday nights from 6 to 8 p.m. And we are going to take the time to just make sure that you know who he is, because he's a famous guy.
No, I'm not.
He's famous.
I'm not.
He's absolutely famous.
Mark, you know what's great? Remember the old days when you first started and you had
The old days.
the dome in front of your house?
Oh yeah, I had a dome out in my front yard, guys. It was like a dome. I mean, I'm the only one in the entire town of Terryville, Connecticut that had a dome in his front yard.
It was nice though. It was beautiful. But the thing is, can you imagine on a night like this being in that dome with the humidity that we're dealing with right now? It is insane out there right now.
Yeah, I would have substantial trouble. So what I would do now is, in fact, I have done, is I have made some great strides. I'm going to turn the Connecticut Observatory into a solar observatory. We're going to be studying the sun. And so the observatory on the East Coast is going to look at the sun all day long. And the observatory out west, Skytour Livestream Sonoran, I have to say it now because we have two going in. We have the Sonoran and we have the Benson. Benson, Arizona is 200 miles away straight from the Sonoran Observatory. And so we're going to be having a lot of lacks of sleep. I can tell you that because I won't get any sleep. You know, let's be fair. I mean, I'm gonna be out there in the daytime. I'm gonna be doing stuff at night. It's just gonna be absolutely crazy.
It's not just that. It's also what your side projects are that you do.
Oh yeah.
The conferences that you do. So you're constantly busy.
Oh
It's
yeah.
like,
Yeah, that's true. I'll be around. I'll be around at a few conferences, won't I?
yes, you will.
Yeah. Yep. So, and next year, because they changed the date of Pine Bush, I'll be able to attend Pine Bush for the first time in 2 years.
Yep.
Which is great. So I'll be able to speak there, and I'll be able to speak at Contact in the Desert if they have me back. So far, it looks like they want to have me back. They really like what I did, and they're very good about letting me decide how I want to run my stuff. So I really appreciate the Contact in the Desert Sky folks, Ron Janix and Brianna Matz. Yeah.
We might be there too next year. So.
I hope so. I want to say hi to we have Mary Spirit is with us. Hey Mary, how are you?
Hi Mary.
Yeah. Hey, if you guys haven't joined us, just go to Skytour Livestream on YouTube. It's our channel, which obviously you're here. If you could be on Rumble too, but join us and subscribe on YouTube, and that way when you hit the notification, you'll get the notification bell, and drop it down and say all notifications. You'll actually hear an alert come in for when we go live. I wish we could say we could do a schedule that was regular, but we can't, and the reason is because we don't. Oh, there goes a Starlink satellite. The reason is because we don't have the fortunate capability of knowing what the weather's going to be. So that's how that works. Catherine. Hi, Catherine is with us. Catherine Messick. And she says, I really enjoyed your lectures at Contact in the Desert and the Skywatch tour. Thank you, Catherine. That's very sweet of you. Very kind. I'm glad you like that.
I've seen numerous presentations by Mark, and they are all outstanding.
Well, I'm glad you like them.
Yeah, all of them. Now, before we really delve into some images and stuff, what the heck happened when you went on Jimmy Church's show and this thing you captured?
Yeah.
Second?
Yeah, just on the first, just before. Weird things happen. And we're trying to actively figure out what it was. But before I went on Jimmy's show, and Jimmy and I have known each other for many years, and finally he decided, I think I'm going to have Mark on again. So I went on his show, and the thing that was fun was that, we communicate well. And Jimmy's a good guy. He's entertainer. He's an entertainment personality, and for that you give him all the credit, man. He knows his stuff. Mm-hmm. But as I was preparing to go live with him, he and I were talking before the show for like a half hour, and about 5 minutes before we go live, I'm reviewing my AllSky camera footage, which my AllSky camera is this camera right here that I'm showing you right now. This is the AllSky camera, and right now the transition is going into night, so the exposures are like 11 seconds right now. So it's really bright right now, but as the night wears on, these are just a few and far between bright shots, and it goes to dark sky with the gorgeous Milky Way coming up, right? But, you know, and I'll show you more about that. But I was going into here, right, and I was reviewing my shots, right, and I noticed on this July 1st, okay, this is the time lapse for July 1st, and I got to nighttime, and as the nighttime approached, I saw this happen. Wow, whoa,
Wow.
What was that? I said. Well, I thought, that's crazy. Now, each of those, now see how fast the stars are moving? Okay. This is, you're watching, if you look over here, these are 15-second exposures taken back to back. Here comes the summer Milky Way. Okay. Out in Wickenburg, you can see a few clouds being generated by the cooling of the desert. All right. So here comes the Milky Way, and every now and then you'll see satellites. Now, early on in the night, you see satellites. And in fact, let's go back to just before the sunset here. Like, say right here. So if you watch, you're going to see a satellite go down here. There it goes. There goes that one. There goes a meteor. You saw a meteor there. A quick flash. There goes another satellite. That was a plane that did a little circle right there. And you see all kinds of things in the sky throughout the night. Almost all of them are satellites. There's one plane that came through and it did a little circle right here. It turned around.
Now, I got a question.
Yeah.
The satellites look fainter than this object that curves.
Yes.
Does that mean that it was at a closer distance to the All-Star? Or
not necessarily, because we caught another one sometime earlier, not in the same night, but a different night. And what we saw, what we were actually seeing was the re-entry of a rocket, a Chinese rocket, that was re-entering the Earth's atmosphere. And we caught it. We caught the Falcon 9 being launched, you know, and when they launch, they make straight lines across the sky. Right. They don't come up and go, you know, and do this like curve and then take off in a different direction, which is what this did. So I'm not sure what it was. I got a lot of people saying fireflies. Well, first of all, there's no fireflies in the desert out in Arizona. Number two, these are 15-second exposures. See, right now, it's 15 seconds. See right there, it says 15 seconds up there. Okay, I can show you that right there. See, 15 seconds. So 15-second exposures are what we're getting right here. And I know I'm a little not burnt out here. It's not showing too well, but 15-second exposures are how much we're exposing per frame. So everything you see here is an elapsed time of 15 seconds. So that satellite that just went through, that and that one there, those are all 15-second exposures. All right. So that's why the clouds seem to dance like they do as the sun's going down. All right. And right now, I'll show you the mode we're in, where we are in our current view. Right now, all right, we're getting to right about, as you'll see, all right, this is where we are right now. We're in that transition to nighttime where we're getting a little bit of light sky, but it's going to quickly go to this. And there go all those satellites you just saw. Those are all satellites zipping through. And then this guy comes through, and it literally has a second one paralleling it all the way. So it makes a curve, and then there's something else paralleling it. Now, I'm going to consult Flight Radar 24. I have a subscription that allows me to go back, gosh, a year, and I'm going to find out if something was flying over here. Now, one of my thought processes was that what we're looking at here is potentially a in-flight refueling operation going on. See, so this makes a curve. There's a satellite starting up here. This curve and this curve, you would think, well, wait a minute, maybe that's a curve from the reflection on the dome of the camera. And I thought that at first. But then what I found was this, as it moved on, okay, and it goes fast because we're doing 15 seconds. I stop it in the other thing. But it goes. You see this guy, all right, and then the other guy. So the thing that's freaky about this is that you see those big bright lights, and then it comes down to a very faint object. And satellites don't turn off their lights. They don't have lights to turn off. They fade gradually. This thing, those lights went out abruptly. So what it tells me is it was probably just some type of aircraft, maybe an aerial refueling operation, and that second other plane was a jet following it around. But this is 9:30 at night, and we should not have seen any reflection on it whatsoever.
I was going to say, could the sun have been reflecting on the object when it initially comes on the screen? That's why it's bright like that?
No,
And then
no.
Okay.
It's actually, from when it first shows up, it's like 9:12, 9:15 in the evening. And the sun has already set, even at high altitude right there. So,
Okay.
no, it's not. And it's weird. Now, so we're still looking at that. But there's our AllSky cam. I built the AllSky cam. I built the whole system so I could track things. We have these beautiful time lapses. Now here's the weird thing. I told Jimmy about it. I showed that sequence on his show, and right after that, the AllSky camera died.
Wow.
It died. It shut down. And when you look at, if I go back to real quick, that was on July 1st. So let's go and look. I'll take you behind the scenes. Okay.
Don't forget me. I want one of these eventually.
I know. So if we look at our images here, this is the behind the scenes. You can see that on July 1st, right here, 07/01/2024, we have our time lapse. That's what this is. This is called this is star trails. So if we look at the star trails, it makes star trails. Okay. Now when there's clouds and a moon later on, it looks a little convoluted, but that's not a big deal. All right. So when we look, you'll notice that after July 1st, it stopped making all of our ancillary time-lapse kilograms are called, and star trails. All right.
Wait a minute. So since that, it hasn't done it since?
Correct. In fact, I couldn't even bring the camera up. It wasn't working until today. And now that I got it working again, I'm going to see if it's going to do this. I got to wait till tomorrow and see if it makes the time lapse for July 5th, which is today.
What would cause that glitch?
That's a good question. It's not like the pictures aren't being done, because here's the pictures it's taking. These are the daily shots, okay, that are being done, and these get assembled into, they'll eventually come in, and these get compiled into a time lapse. So it's pretty interesting. I just don't know why this failed right after I showed it on Jimmy's show.
They're out to get you, Mark.
Yeah, I know. Everyone loves to say that, but that's okay, because I'm ready for him, thanks to Commander Cobra. All right,
Yeah.
I've got my glasses on, my UFO glasses.
Oh my
I
gosh.
don't know if you can see those. Commander Cobra's a test pilot, good friend, and they asked me, along with Bill, to co-host on UAP Crossfire, which is a show on KGRA Thursday nights from 8 to 10. And I haven't made a full decision on that yet. My time isn't my own sometimes. But I've agreed to do it.
So far, so good. So far, so good.
So far, so good. I've agreed to do it one more time so far. All right. All right, so those just joining us, for you guys that haven't seen this before, I'll give you a tour of this screen here. So this is our main screen in SkyTour live stream. You just saw the AllSky camera. Well, now I'm showing you the main system. Okay, so there goes a star. That wasn't Starlink. That was a different one. Starlink satellites at 1 second intervals are actually quite long, much longer than that. A little longer.
So what would that be? A plane? Like what would
No,
that
no,
be?
that's another satellite. That's a different type.
Oh,
Of, yeah,
okay.
yeah. Okay, so let me just give you a rundown of what we're looking at here. And luckily, I've got this thing called a telestrator built in. So this right here you're looking at, this is our telescope control system. This is our telescope controller. And if I were to tweak any of these buttons, you'd see this show up. This is the telescope in camera 1. This is the same telescope, camera 2. This is that loudmouth sitting over in the corner. That's me. Okay. And this is the camera control cluster over here. The camera focus is right here. Okay. And I'm going to show you the most important elements in this entire system. The most important elements that you would want to look at is this right here, right? That's the exposure. And this right here, the gain. So the gain is set to 200 right now. What's the gain? The gain is how sensitive we've made the sensor on the camera. Okay. And the exposure is how long we're going to expose that sensitive camera. Okay. This allows us to capture some really cool things. Now we're waiting for it to get really, dark out there, but I'll give you an example. We'll come over here and we're going to set this exposure now. So I'm up there in the corner, or up here. I'm going to set this exposure to say 5 seconds, and you set in terms of milliseconds. So it's 5,000 milliseconds is 5 seconds. So now it says 5.00 seconds, S. Right? So a 5-second exposure, down there's a progress bar that you can see. And when it's over, you'll see a 5-second photo appear right here. All right, and there's a 5-second photo. Notice there's more stars. Okay? So what we're going to do is we're going to let it get a little bit darker. And we're going to also do a setting here. I call this our low light mode. All right? So it's like using a night vision system effectively.
Like a filter, yeah.
Well, it's a night vision, basically. So we're kind of seeing in the dark. Okay, and this allows us to see what's going on. You'll notice that you can see that the screen sort of changes every now and then. You see a little flicker, like the noise changes. And that's actually the camera, refreshing the screen. First thing I'm going to do, I'm going to get us to a location just outside, away from Spica. That's this star in Virgo. And when we bring up our system here and we center it up, you'll see that we're coming over to Spica right there. And if we zoom out, you'll see that that's Alpha Virgo, the brightest star in the constellation Virgo, who is the Virgin. And there is Virgo. Okay. And so you can see Virgo is kind of low to the horizon. And what's rising now at the other end, all right, is Libra, the scales. And here comes the summer Milky Way with all its glory. And we're going to check out a few things here that are really neat. Okay. Among them is a amazing location up here in Corona Borealis. And we're going to go there first because we're doing a study on a particular star up there called the Blaze Star. Now this star is, we're going to go there now. I'm going to tell it to go. So I just told it to go. So watch the telescope now over here. All right, there it goes. That telescope is 2,600 miles from me right now. And I'm running it from my observatory bunker here in Connecticut. Everybody's got a bunker, I guess. All right, so this looks about right. And so here's our field. Now, I'm going to use this field to focus the telescope because it's not quite focused.
Yep.
Again,
Sean, if you have a question in a little bit, post them and I will ask Mark your questions. I'm sorry, Mark, go ahead.
No, that's fine. Thank you very much. So please do. They can probably hear me too, right?
Yes.
Okay. I'm going to get the focus done now. This is a technique Now, the author of this particular program, this program is called SharpCap. The author, great guy. He actually did a really cool thing. I asked him if he could set up an autofocus routine, and he said, "Yeah, sure." And it took a little time, but he got it done. So right now, I can bring up this focusing routine. You'll see these are little tiny donuts now. And what I'm going to do is start an autofocus routine. What it does is it's going to create a parabola of focus points where it's out of focus, more in focus, fully in focus, and then getting out of focus. And it's going to find that center point, and it's going to make that the best focus point. So it's going to set that up. We just let it take its time to do it.
That's incredible.
Yeah, he did a good job. That's Robin. Robin is a really good thinker, you know. James Hyde's with us. Cosmic Ray, what's up, guys? Creeptasia, how you doing? Damien K, how you doing, brother? Good to see you. Yeah. So our telescope is a 10-inch system. What you're looking at right here above my head, that weighs around 275 pounds. And it's on this massive mount. We're changing the mount because we want to get away from the original mount the telescope came with, because that original mount is actually old and it sort of acts up now and then. So we bought two new Skywatcher EQ-R Pro mounts, one for the Benson telescope, which I showed the other night, and we're going to put this one on that new mount, and we're going to raise it up higher in the building, so it's actually going to be able to have a more of a view than the other telescope, that this telescope does right now. Okay, if you notice, our parabola's been done. Here it is, and there's our focal point. And what you'll notice is I could tell to go to the best focus point right now, but it's going to determine that right now, and it's going to then go and there it goes. Now it's moving my focus on the telescope right to the best focus position, and look at those stars.
Wow.
So now I can just say, all right, let's get out of there. We're done. And the next beautiful thing that I can do with this program is this. I'm going to annotate this system. I'm going to say, where are we in the sky? And the telescope knows where it is. But if there's anything in here that we should know, we are now going to get it labeled on the screen for us. So check this out.
Mark, in the near-term future, is there any way to use AI as an assistance to this? Is that something that's viable?
Yeah, I don't see why not.
I'm just saying, there's a lot of pros and cons when it comes to AI, but for something like this, it might be useful.
Oh, I agree. I'm going to move a little bit to the west here and re-annotate. And then I'm going to sync up the telescope and give it the coordinates. I think the Blaze star is right in here, so I'm just going to have to annotate. Might be this one. We'll see. I'm going to go annotate, and I'll do it again because it's going to have the previous annotation. So I'm going to do it again. That is not really where this is. It's taking a sample, and now it's going to search and re-annotate the screen. Okay, I didn't find it yet, so I must be gonna check where I am on here. Let's go to Alphica. What was that?
Is what he's using right now like a plate? I don't know what you mean by that.
I think he means plate solver.
Oh, okay.
And the answer is yes. I am plate solving. Okay, this is the brightest star in Corona Borealis, the Northern Crown. And so if I take that and I come up and center it up, all right, which I'll do right here. I'll move the telescope west a little bit, and then move the telescope north, and center it up. In in an observatory setting, especially a professional observatory like this, it takes time for things to happen. It just doesn't just move to something right away. You've got time, and you've got some some hardware you're slinging around out there. So everything has to move. It's like when you look at the Perseverance rover on Mars, they have it move like 4 inches at a time, maybe a foot at the most. And you say, "Come on, go, go, go!" But
the amazing thing is, Mark, you're doing this from thousands of miles away too.
That's correct, and so I have to be careful and measured. We want to make sure that we don't have it go and do something it's not supposed to do. And you got to be careful, and that care is how this thing has lasted. 3 years now?
Does it have to be in the crosshairs to get it exact?
Well,
or can it...
now it's in the middle there, and so now if we come over here and we center and we look at where it thinks the telescope's pointing versus where it's pointing, well, you see, now we have to align that. We have to say, I want the telescope, which thinks it's here, to be looking like it, to know that it's here, because we're there. That's where this is right now. It's looking at that star called Alphecca. So I'm going to tell the telescope mount, make that your new center point. And you see, there it goes. Boom.
Wow.
So now it's there. So now when we go and say, let's go to the Blaze star again, it's going to probably put it almost dead center. Right?
Wow.
So here we go. We're going to tell it to go there now. And so we'll go and check it out right now.
That is wicked.
Yeah. So it might be that one then.
Is the light at the Benson locations, the lack of light, the same as here?
No, it's actually a little darker.
Wow.
Yeah, it's actually a little darker. Okay, let's see how far off it is. Okay, we're going to do the whole sky view right now. This is from the previous time we did it. It doesn't dynamically update. So we should see the Blaze star in here now.
What's significant about the Blaze star?
I'm going to show you.
Calm down, Bill. Wait.
Where is it? Oh, there it is. Right there. Okay. Okay, so this is, it's also known as Hipparchus HIP catalog star 78322. And what is that? Well, this is a star that's actually a red giant paired with a white dwarf. Now, what that means is you had two normal stars that were orbiting each other for a long, long time. And then at one point, the one star evolved off of the fusion, the hydrogen fusion burning phase, and grew into a red giant. And then it shrunk down to a white dwarf. Meanwhile, the other one, just a little behind it, also went past its hydrogen fusion phase, and it went into a red giant. And that's the state it's at now. And it gets so big that it fills a thing called the Roche lobe. And that, look at that, that's a Starlink satellite. It fills the Roche lobe, which is the largest size, largest diameter that a star can be in a binary system before it starts leaking material onto the second component, the second star. So this star has been leaking material onto this white dwarf. And every 80 years, the hydrogen gas that's leaking onto this white dwarf gets to the point where it suddenly goes into runaway hydrogen fusion, like the stars do, but on the surface, because it gets hot. These are very, very hot stars. And when that happens, the star gets massively bright. And that happens for about 3 or 4 days, and then it gets dim again. And then another 80 years from now, it'll do it all over again. So that's called a nova. Not a supernova, but a nova.
How far back in time are we looking?
The distance to this star. And I think it's like over 2,000 light years away. Let's go see.
Wow.
Yeah, it's 2,695 light years away. So it's actually pretty far away. So the nova already occurred many times.
That's what I'm saying. That's why I asked the question. That's where I was going to go with that.
Oh yeah, yeah. And the name of this star is we call it the Blaze star. Its actual name is T Corona Borealis. So I'm going to put up here T core bore. And that's up here in this descriptor up there. And now when I save this, it's going to go up to the cloud and come down to our server, where if you go here to skytourlive.org, you can actually go right to our server and download every image we take for free.
Where do they go? To skytourlive.org?
Skytourlive.org, and as you scroll down, you'll see Take Me to Cool Pictures, and it'll tell you what to do. Now, that's one way. The other way that we're coming out with, it's going to be available soon, we have an app for iPhone, Android, PC, and Mac. And you'll be able to look at years and years of our observations and check out like every single Orion Nebula photo we ever took, every single blaze star photo we ever took, every single globular cluster photo we ever took, etc., etc.
Wow.
And you can do real science with these, okay? Because Izabela Melamed, who's in Sofia, Bulgaria, she is one of our Uber users and friend of SkyTour Livestream. And Izabela, who wrote the app, wanted to do research with our data. And guess what? She found asteroids with our data. And she also found stars that have vanished.
Interesting.
Yeah. And I just read an article, and I think it was either Izabela or Daryl that sent it to me. And I would think that the way it happens is, if let's say we're looking at this star, and you look in this field, in a year, and this star is missing. Wait a minute, how could that be? Well, it points out a potential cosmic catastrophe that occurred. Another Starlink satellite, a cosmic catastrophe that occurred that didn't leave any evidence. Normally, when a star collapses, okay, it goes and runs out of all its fuel, it'll go into a supernova and explode and obliterate itself and make this gigantic nebula in the sky, and it gets so bright you can see it during the daytime. Well, there's a theory now that maybe some of these massive stars, they collapse and they just go right into a neutron star or a black hole and never go supernova. And that's weird, because that's something we've never seen. Izabela's here. Hey, Izabela, I was just talking about
Hi,
you.
Izabela.
Yeah. Bill Skywatcher's with us tonight, Izabela. Fantasy's with us. How you doing, Fantasy? Michael Hedrick, how you doing, brother? And Creep Tasia, I said hi. Sam S., what you doing? I think Sam S. likes Izabela. And JSCO 77, one of our original winners of our Sky Tour contest, we sent him a telescope. He won a telescope. Nice. Yeah. Rockstar's with us. How you doing, man? Yeah. So this is great. All right. So here's what we're gonna do. The reason I haven't been wasting your time, I've been waiting to let it get a little darker out there, and we're gonna try now a 15-second shot here. So there's 15 seconds, and now we're going to add another screen you haven't seen yet, and that's this one right here. This is our stack screen. What we're doing is we're taking an image, and then we're going to take a second image, align it with the first, and stack it on top, and just keep making a sandwich of all these, a stack of all these images, and it makes a noise-free image over time. So if you can hear that clicking, that's a mouse trying to get into the no-kill trap next to me here. I feel like I want to help it. Like I said, do you need help, kiddo? I'll help you out. All right, let me get rid of this ultra-bright thing here, and I'll change everything. Okay, there we go. There's the blaze star. And if you want to see it again, I just have to bring this up, and there you go. All right, so there it is, and I'm going to also... Mouse is crazy. Yeah, you might help him and help you. It's trying to get caught. I can't believe it. All right. I'm not going to try and take him out of the trap now or get him into the trap. All right, so here we go. So here is the blaze star, and this IC 1166 over here is interesting. It says it's a galaxy, but it also says NEO, which means near Earth object. So I don't know what that means in this case, because I didn't think this was showing us any NEOs. But there you go. That's kind of cool. I like how this does the annotation and shows us all these things. I'm going to save this image with annotations, and it's going to go to our T-Core board directory on the server when you finally go out. Actually, it's going to go and you'll see this. Here's the exact picture you're going to see, and there's actually a label on this little crosshair. That's the image that was saved just a moment ago. So in about 30 seconds, this image will hit our server, and everybody can have it. I want to say hello to Kathy. Kathy Prentisak, how are you? You must have something good in that. I put some peanut butter in there, Kathy. And I think the thing is really getting irritated. It's trying to get in. And it's not a big one. It ran across the floor earlier. It's really cute. And it's really small. I don't think it has the weight to cause the bobblehead trap lever to go off. And that's it trying. The mouse is relentless. That's right, Creeptasia. Okay. So, satellites make trails, and as you can see, but they're only on a single frame. And as you take more images, the dark of space will overtake that brightness eventually and just automatically remove the trails over time. But you can see the red giant here, and when the star finally goes nova, which by the way, it's destined to go nova this year or possibly later this year, but
wow.
we're checking it out and watching it because I want to see when it happens. I like to see it when it happens. You know. Now, this screen down here shows us our red, green, and blue curves, okay? This is a color correct, so it'll align the curves under each other, and it will give you the correct color. And then the white curve you see here is the average. So, okay, Mousy. So this is our black level curve. If I move it off of the curve entirely, it's going to get kind of washed out and bright because it's just, you know, it's not a bright sky out there. But what it's doing is it's actually just lightening the view as if you're turning up the brightness, okay? So you can do that in any dark sky and you'll still get a bright sky. All right, so then we're going to bring this right up to just before, this is a black level, so we bring it right up to just before the peak. And that'll be our maximum darkness. And then this one here, this is the one that allows us to pull out data. If I pull this all the way up to here, you'll see it gets brighter, but it also gets noisier.
Yeah.
See how it looks a little mottled? And we can get rid of some of that by turning on this here. You'll see, watch now. Boom. It gets a lot better really quick, but it's not 100%. You're seeing red. That's the light of sunset that's still kind of polluting our view. It takes a little longer for the sun to finish going down, which is why I've got this way down here. There you go.
That looks great, though.
Yeah. So this is the Blaze star, T-Core bore. I'm going to save it here. This is 17 shots. You can see right there. 17 shots. And we have a filter in here called the full width half maximum filter. And what that does is that basically is measuring the star diameter. And if it gets elongated from wind or whatever, if it gets above our threshold level, which I have right now set to 6.93, then it'll reject the frame and it won't add it into our stacked image. So these are all the frames that have been added together to make our image here. All right.
Wow.
Yeah, so it's pretty cool. So I'll save it, and it's going to save an astronomical file format called FITS, and then that's the one we use to process it and do image processing. Then I'll save it exactly as seen, and so what goes up to the server is this image, exactly this image, right, with all these satellite trails from the Starlinks that came through. That's pretty crazy.
Yeah, there's like at least 4 there.
Yeah. Yeah. So that's that. So now we can do this. We can move on. And I'll show you something that I think is really cool. We're taking advantage of the fact that we don't have a moon right now. Well, we still have a moon. It's just on the other side of the planet.
Yeah.
Right. All right. So let's do this. Let's go check out another beautiful object, which is right nearby. And this is up in the sky. It's almost 80 degrees up in the sky. So the telescope's going to look way back and point toward the back of the building here. All right. So here we go. And the telescope's going to start moving. And I'm going to go back into low light mode while it's doing that. All right. Okay. Well, it's in there already.
You got in?
There it is, right there. Mousy, I'm on the air. The least you could do is have a little respect. Ay, ay, ay. Okay.
How close is he to you?
He's about 4 feet. You know, he's.
Wow.
Well, I saw him run around yesterday, so I figured I'd put a trap down there to catch him. JSGO77 says, I wonder if anybody will watch the moment the nova happens. All eyes are on the nova potential right now. So, yeah, there's going to be a lot of people watching for sure, without a doubt.
And let's not forget,
including us.
You were one of the few people to catch that meteor hitting the moon.
That's right. That's right.
So
we have a history of finding these things when they happen. That's true.
Yep.
Okay, so I'm gonna do this. I'm gonna drop us down a little bit, move us a little bit westward, which means move the telescope in that direction, and center this up a little better. Okay. Now, you'll see right here that it says searching up top there. That is searching for a guide star. When it finds it, it's going to start showing us numbers, and it's going to be percentages of correction in the east-west and the north-south direction, and that's called right ascension and declination. So your RA and dec. So when this starts counting down, or getting numbers, we can actually start taking pictures. There they are. Okay, so what I'm going to do now is I'm going to do a 20-second shot of this. It doesn't need it, it's really bright, but we'll do that anyway. So here's a 20-second shot on the way, and again the progress bar down there is telling you that. And now we're going to go into our live stack again, and this will show you the previous image we took because that's in the buffer, but I have it pretty bright right now, and this will wipe it out, which is good. Night of the Mouse. I should change the title to Night of the Mousy. Yeah. Oh, look at that. What do you think, guys? Isn't that beautiful? That is stunning. This is the Measure 13, the Great Cluster in Hercules. Isn't that beautiful? Now,
it is.
Show you something else. Daryl likes to point this out too. And if I move this mid-level down just a little, it's going to allow us to see the center better. Okay? And I want you to notice what's in here. If you notice, you have this line of stars here, and then you have, a dark line here, a dark line here, and a dark line there. Do you see that? One.
Can you zoom in more?
Two. Yeah, I can. I can certainly zoom in more.
Wow.
So you can see this, this, and this. See that? And that's actually just a chance orientation of the stars, and it looks like a propeller. You got one here, one there, and one there, and that's called a propeller in this particular.
Mark, what is the source of the light?
Hundreds of thousands of stars.
That's it? It's just because of the cluster?
Yeah, this is a globular cluster of stars. And let's take a look in our planetarium. It's attached to our telescope. And this will show you that we're looking at... I'm waiting for it to come up.
But Are they at vast different distances from each other, where it's just that they're in the same general area that we're looking at? That makes it give it the appearance that they're all together. Are they spaced? You know what I mean? It's
I know what you mean, but no, they're actually they're definitely they're all here. You know,
wow.
and
Wow.
now this cluster is actually, if you want to think about how far away this cluster is around 25,000 light years away. That means you're seeing it as it was 25,000 years ago.
The question that comes in from my chat, Sean, can you ask if they are interacting with each other?
Oh yes, they are. And talk about a nightmare, guys. When you talk about this many stars in one area of space, they're all gravitationally interacting with each other. So it means that they all probably have these very complex orbits around each other over long period of time. And that complex set of orbits is really interesting, because what it means is that we're going to have, like, if we had to solve the equation for how the complex gravitational orbits operate here, it's called an N, as in, you know, LMN, okay, N number, N-body problem. And N-body problems get complicated when you have 4 members. You know, how about 500,000?
Oof.
You know, now what are you going to do? What about 100,000? How about 1,000? You know, it gets
Risk of collision, Mark, in this situation?
never seen in the history of the universe
Okay.
so far.
Okay.
Because as close as they look, they're 25,000 light years away. So if you got near them, you could get in the middle of it and you'd see bright stars almost everywhere you look, but none of them right next to you, right? They're pretty far from each other.
Right.
Yeah, but they are gravitationally bound.
Wow.
And I've said this before, these are halo objects. These are objects, okay, these objects are, they're called globular clusters because for their shape. And these clusters are in the galactic halo. They're outside the galaxy and orbit the galaxy. Now, this one's 25,000 light years away in the direction of the constellation of Hercules. So it's not quite on the galactic disk, but there are some clusters that are much closer to us, actually, relatively speaking. And they're on the galactic disk, and what's happening there is they're actually plunging through the galactic disk because they orbit the whole galaxy.
I was going to ask that. So are they being influenced by the galaxy itself, from the gravitation of the entire galaxy?
Yes, they are. In fact, what happens is every time they plunge through the galaxy, it may be that some of these outer stars get lost to interactions with other stars as it's passing by. Or maybe you're gonna find that this cluster grabs some stars from the galactic disk and pulls them along with it.
That's amazing.
Yeah.
So the influence it could go either way.
That's the way it seems to me. Yeah.
Wow, that's amazing. Wow.
And Michael Hedrick, always good for excellent questions, and he's one of our top attendees. He asks, what round sky object might be visible to the naked eye on December 25th in the northern hemisphere? I saw something in 1998, maybe. Didn't move. Star cluster, nebula. Oh, yeah, you probably... you could have been looking at the Pleiades, Michael. With the eye, it looks like a fuzzy blob. So it's possible you're looking at that. But I need to know more detail. You know, Kathy Prunisic says, gravity rules, man. It sure does. But look how beautiful this cluster is.
Yes.
And let's see our filter. You'll notice that we've got excellent night tonight so far. We don't have any wind, so we're not finding any of our images have been rejected. All right, so I'm going to change the name here. We're going to call this Mesher 13 M13, and I'm going to say GC after it because it's a globular cluster. And then we're going to save it. All right, and now it's saving the FITS file, that astronomical file, and then we'll save it exactly as seen. And once again, You go to our server, and this is what you get and download for free.
Nice. Look at that.
Yeah.
Beautiful.
Oh yeah, you can zoom in on this and look at it. I mean, make it a desktop thing if you want. Put it on your desktop. And we offer those for free. Now, we also do really, really good hyper processing, and I've made some posts on my Facebook and on the SkyTour live stream Facebook group, and you see some of the latest images from things we've captured. We've captured the Lagoon Nebula lately. We're going to try the Trifid again tonight, and we did the Dark Horse Nebula, which is a dark nebula. And this particular camera is tuned specifically for this telescope. We have what's called the best arc seconds per pixel rating for this particular camera and this particular telescope. They go together like butter goes on toast. So it's really, really cool. So I took a picture for the first time with that new camera of the Lagoon Nebula the other night, and it was stunning. All right, we're going to save this again.
Sean says, when can M31 be seen with the naked eye? Do you know?
Yeah, we can look that up and, come up with that answer. It'll be in the northeast to begin with. Right now, it's down low, and we have to wait for Pegasus to come back up. Because Pegasus is going to come up, and at the upper left of Pegasus is the star Alpheratz, and that's where Andromeda starts, basically. Yeah. All right. So let's get out of this and go back to our low light shot. By the way, Bill, thank you for coming out tonight and hanging with us. It's
Absolutely.
Very nice of you. All right. So there's our low light shot. So this is a live 1 second feed from the observatory. You watch the image changing a little bit here. As it updates, you'll see it's updating. The noise is changing a little bit. So let's go in here and let's go and zoom out of this for a minute. Let's try again. Okay. All right. So I'm going to come over here now and come down here. Right now, we are in a good position to go see this really cool nebula called the Blue Horsehead Nebula. Now, I've been taking pictures of this over the course of the last few nights, and I did the Dark Horse, which is right here. But I want to try and see if we can capture another one for you guys. Let's see if this one is ready. Since we have some new faces, I'd like to show them this one if I can. We might be able to look at this one now. We might be able to check it out. The reason I say might is because if you look right here, this is the edge of the observatory's east wall, and we're leaning to the east here. And I want to make sure that we get up high enough to be able to see this object right here. And if we can't, we'll just come back to it. We could probably see some of these things that are a little higher, and we'll do that if we have to. But it's all beautiful. So let's try it out. All right. So remember, Meshia 13 is already on the server, I'm sure. There goes the telescope, leaning over, trying to get to this thing. Let's hope that it can see it without interfering with the wall. It looks like it's gonna be close. But there it is.
That is so cool to wait. It just to see that moving.
Yeah, this might be close. We'll have to see. Yeah.
When are you planning to put the new mounts?
Well, we're gonna get the Benson telescope up and running, and then we're gonna retrofit this one. And that is gonna happen, I think, over the next couple months, because I gotta actually. Definitely over the next couple months, because we actually have to build the housing for the Benson scope. And I'm going to talk to a metal fabrication company up here. I've got it all designed, And I want them to laser cut all the steel and punch all the holes, so all I have to do is assemble it like a kit out at the site. All right, so we'll see if they can do that. I'm going to zoom in to make sure that we have not changed focus.
If you need help in Connecticut when that happens, let me know.
I will, thank you. Okay, we're just going to do one more focus run here. What happens is the telescope goes through something called mirror flop. When it goes and looks up into the sky, the mirror moves a fraction of a millimeter, more than enough to cause this. Now, if you notice, when you go out of focus here, you see how they're not complete donuts?
Mm-hmm.
They look like little C's.
Oh, yeah.
You know what that is?
What?
That's the edge of the building interfering. So I know that the building is now interfering. All right, so we're going to look at something a little bit higher so we won't have to deal with it. Because it'll end up showing a red haze because there's a tiny red light, because our camera's on the front of the telescope, not on the back, like most. So the telescope being at the front, the camera being on the front, means that there's a little tiny red LED. That red LED shines a very imperceptible light on the wall of the observatory, but the very sensitive camera picks it up. I won't cover it because I want to know if something's blocking my view. And by going out of focus, I could tell, and I could certainly see we are. All right. Mousy, respect, please. All right. We'll come back to this, but don't worry. It's worth the wait. You can see the red nebula, as a matter of fact.
Yes.
All right. Let's see if we can go to this cluster. And we're going to move a little higher. Not very far. And we're going to see, there it is right there, where our target. And we're going to leave it kind of up there because it borders a star cloud right here. You have no idea how many stars are right here, but it's absolutely incredible how many stars are here.
I see it already.
Oh, you don't see anything, man. So we're going to just do a focus run here, get our stars perfect pinpoints. And when I zoom in here,
I can imagine someone
see,
taking all the photos that you have and putting it on their ceiling or around their room, like encompassing that. You know, it would, because they're stunning, and you could probably put a collage together that fits like a puzzle.
Yeah.
It would be outrageous.
Yeah. This focus may not work because, as you can see, I have little C's. And I'm going to try and focus anyway and take this picture. It's going to be using the equivalent of about a 5-inch telescope because just about half of the aperture is blocked by the building. But I'm impatient. I want you guys to see this cool stuff.
I'm more impatient than you are. You know that.
Yeah, you dropped 1 billion years on me during a talk. Why don't you explain to people what you did?
He was doing a presentation. Was that in Middletown, that one? Or was that in Pine Bush?
That was for Pine Bush.
Yeah, but it was at the Middletown location at that time when we were there, because it was you, myself, Jade, and somebody else. We were all having a good time outside because they told us to go shh, because we were, Jennifer Stein. Remember, Jennifer Stein said, "You guys got to go outside," because it was that. I think it was that night, or was it in Pine Bush? But regardless, so Mark is doing his presentation. Our friend Eric Hartwig, who's the MUFON State Director for Massachusetts, he's on one end of this huge roll that Mark uses for his presentation that goes to the timeline.
Yeah, basically I take the timeline of the Earth,
yes,
and I show people the evolution on Earth of life and everything that occurred on the Earth with a roll of toilet paper.
And I dropped it.
And he dropped 1 billion years on the floor and it went all over the place. I was like, ah!
Oh my gosh, that was
Yes,
crazy.
the whole planet shook.
But Mark, of course, what happened, he turned it into a humorous thing, and it was great. And I was actually laughing because I knew what I did, and I was like, "Oh my gosh!"
Well, everybody knew what you did.
Oh yeah, obviously.
Yeah, it was fine. It didn't bother anybody,
Oh.
least of all me. I actually used to use real toilet paper for this, and I would write on each sheet all of the milestones that occurred. People get to see when pollinating plants arrived, and it turns out they arrived after the insect pollinators were evolved. So the insects had this capability, but nothing to pollinate, and the plants literally responded through some type of mutation in evolution to say, well, let's use these insects to help spread our genetic material around. All right, and that's just what happened. So it was weird how one begat the other. You would think that maybe the pollinating plants would arrive and then insects would arrive to take advantage of that. But no, it was the insects that would be the pollinators, or the move the pollen around. And then the plants said, hey, let's use the insects to do our dirty work. And that's exactly what happened. Mm-hmm. Okay, here we go. This is 25 seconds on this nebula. I'm going to go into our deep sky mode here now. So the sky looks black. And the live stack comes in, and we'll see the last object we took a picture of, which was Measure 13. This is up on the server now. And you can see our progress bar. So I can clear this because our progress bar is taking a new image. This is a buffer from the last time. And so now you should see the Scutum Star Cloud and Measure 11. Yeah, and let me just zoom out so you can see better, because there it is. Now it's red because it's being partially occluded by our wall, so I can color correct some of it, and this can correct a little bit of the color. And when you'll notice, you'll see these dark lines. You know what these are? This is dark nebula. And it's within this dark nebula where life was first formed. I just wrote up something on my Facebook page and all over the internet, actually, on many different Facebook groups. I just put up a little discussion of this dark material, what it is, where it comes from. There's a lot of dust here, this black dust, and this black dust is made of things like methanol, which is a carbon atom and 3 hydrogen atoms and an OH added to all that, so CH3OH. And there's carbon monoxide, CO. There's carbon, there's silicon grains, and then there's ice, water ice, ammonia ice, formaldehyde, and this material and hydrocarbons that are all conglomerated onto the grains, and then it makes molecules of those, and this is what we see here. And some of them get very dense, and they're all mixed with hydrogen gas. Is
that the color? Is that what the color represents?
Yeah, actually, this color here is actually pretty close. There's a little red cast based on the observatory occlusion for its wall, getting the red light in it.
See that, yeah.
But for the most part, when we look toward the center of the galaxy, which is not exactly here, it's a little bit farther south, but when we look here, this coloration we're seeing is going to be more yellow because the center of the galaxy has older, more yellow stars. It's the disk stars that are bright and blue, like we see in Orion, and the Orion stars are in what's known as the Orion spur in the disk that we're in.
Interesting.
Yeah. And so this is Measure 11, and I'll call it M11. Yeah. It's having trouble stacking because where you got the edge of the wall in there.
Yeah. You can zoom. Can you zoom in a little bit on that upper
Yeah,
area?
sure. It'll be a little noisy because we have to stack more here, but
Yeah.
there we go. It's going to be a little better here.
It's amazing.
Yeah, there's a little ways to go here. And in fact, it's way off the curve here when I move
But
this
still, Mark, just to think that's out there. You know that.
in. Oh, yeah.
It's almost hard to comprehend how much is out there.
Yeah, I mean, doesn't this look like you're looking at a picture of a wet blacktop driveway?
Yeah. Oh my gosh! Now you're making me think of that commercial with the with the protective coating for the outdoor pavers. That's what it kind of looks like.
Yeah.
It's stunning. Listen, this is stunning.
Yeah. So we'll save this right here. Save exactly as seen. And let's see if we can get to something different. Let's see now. I know. Let's try to look at a cluster. The summer beehive. This is kind of a cool little cluster. We'll check that out. And we'll go back to our low light mode. Okay, telescope is kicking over to that.
Mark, would it be an advantage to have a telescope, say, in Australia to see different points of view in the sky? Or
Absolutely. In fact, that's one of our goals, is to try and get one down under.
Yep.
We would love to have a telescope in Australia. Okay, let's go up to this one, and we should be able to check this one out. Yeah. See, now we'll be out in the open area. All right. Okay, let's this is the summer beehive here. Let's take a look now at in here, and this here is also called the Poseidon's Trident Cluster, which is kind of a weird name for it, but okay. All right. So let's do a 15-second shot of this guy. All right, and we'll come out of low light mode, go into deep sky mode. And we'll clear this last one. You always wonder how many stars are there, and if you look, you can see that there's a lot of stars that were hiding in that area. Look at this. These beautiful stars. Beautiful cluster. And now, the stars in this cluster are younger, okay, because they formed in this cluster and then are migrating away. They're subject to gravity too. But even though they're subject to gravitational interactions with other nearby stars, they aren't necessarily going to be, so bound that they never migrate apart. They certainly will. And our sun was born in a cluster, maybe of this many stars. And when it was, our sun ended up migrating away. So there was a study to try and find other stars like our sun. I mean, siblings. Stars that were born in the same nebular cloud that we were. And that would make a star that's exactly like our sun.
So would this be somewhere where exoplanets are most likely to exist because of that?
There's a better chance that habitable worlds could exist in a cluster like this, because of the fact that these stars, depends on how old they are. Some of these clusters are extremely old, and older clusters stand a better chance of life because here it took 4.6 billion years. However, we had a lot against us. We had bombardment areas that made the Earth molten again at one point. We had asteroid impacts. We had extinction events, 5 major extinction events. The Permian era extinction event 200 million years ago. Wow. That got rid of 96% of all life on the planet.
Wow.
Yeah. You know, here you can see we had one rejection because I have us at 6.93 and 7.07 was a rejection. So we'll see what the next one's going to be here. Yeah, so, there was a lot going on and a lot to consider, with our planet. Okay, this is 6.67, so now we're good. All right. So now, that said, I'm going to change this to the summer beehive.
Has there been any new interesting data coming in from the web?
No, the web is defunct. No, I'm just kidding. The web is making phenomenal discoveries every day, actually. One of the major ones that I think is really understated and underplayed is the fact that the web may have found a compound called dimethyl sulfide in the atmosphere of one of the planets it was looking at. Why is that such a big deal? Dimethyl sulfide is something that you would smell, and you can smell it, and you already have. Dimethyl sulfide is the smell of the sea. When you go down at low tide, that smell of the clam mud, the clam flats we call it.
Yes.
That's dimethyl sulfide. Okay.
So does that indicate there's oceans? Is that what you're saying?
No, in fact, it actually indicates very strongly that there's life, because only life produces it on Earth. No other thing produces dimethyl sulfide.
Wow.
So if Webb is confirmed to have found dimethyl sulfide on this water world, by the way, then Webb could be stated to have likely found life in another world for the first time in human history. That's pretty cool, isn't it?
Oh, yeah. How far? Do you know?
I'm trying to remember how far away this Kepler planet is.
Not that it matters, because we're not getting there anytime soon, but I'm just saying.
No.
But it's still an interesting little tidbit there.
Yeah.
That's actually very insignificant. It's not tiny. It's actually very significant.
Yeah, it is. Michael Hedrick asks, was the Yucatan impact an extinction event? We call that the KT boundary event, or Cretaceous Paleogene boundary event, or the asteroid that killed the dinosaurs, right? That was 65 million years ago, approximately, and it was an asteroid that struck off of northern Yucatan, as you stated, and it was an extinction event, and it took out. Well, what it did was it sent a pall of dust up into the air, and that pall of dust ended up blocking sunlight that prevented plants from actually thriving, and the plant-eating animals was running out of their food, and they died off. And then the meat-eating dinosaurs that ate the plant-eaters didn't have food, and so they died off. So in short order, this extinction event took hold, and a lot of them died.
Another question is, are you able to see the web with this?
That's a good question. It's 1 million miles away, and I have to look at its magnitude to see like how bright it is, because I know we can pick up magnitude 18 and 19 objects, and because a lot of the geosynchronous satellites are magnitude 17, and we can see those. So it's something I've got to see about. I don't know for sure, but once I know the brightness of the web, then I would be able to tell you. But that's an excellent idea. I'd love to do that, actually. Yeah, I'd love to do that. All right, so here's the little beehive. Okay, we call it the summer beehive actually. So we'll save that now. And we'll save it exactly as seen. And so when you go out to the web site, this is the picture you'll get for free. To enjoy that. And again, if anyone wants to ask about the morphology of clusters and how they form, what their destinies are, where they're going, be happy to look at all that. Okay, let's now go and go back to our low light mode. So low light mode is very helpful because we can see our target in the view.
Someone just said it says Webb is apparent magnitude of roughly 16.
And we should be able to see it. We'd have to pick it out against the stars.
Yep.
We should be able to see it. All right, let's bring back our guide here. Okay, let's go here. Back out a little bit. We could go. Yeah, we got to get up much higher in the sky for these things. Let's go over here. See if we can get our way up to Canis Venetica, Canis Venetici. I don't think that's gonna work for us, but we can find out. Altitude here. I'm trying to read that screen. Oh yeah. Plus 45. Maybe. Let's see. All right, let's see if we can do this. This might be doable. All right, we're gonna go for it. Telescope swinging all the way around to the other side of the sky for the moment. And it's gonna end up 41 degrees up, so it should be slowing down right about now. And let's see if we can. There it is. That's our target. So what this is a galaxy, and this is a cool galaxy, which we'll see. It's called the Black Eye Galaxy. And as far as how far away it is, it's 24 million light years away.
Oh my gosh.
Yeah, so it's quite far. So let's bring that up into the view. Bring our crosshairs up to get it in the view here. We don't have to do this, but I want to bring it up enough so you can actually see it centered up. And we'll go east.
Just that number, what you just said.
I know.
It's just crazy.
Oh, it is. 24 million is not close. I can tell you that.
Light years. That's the thing. Light years
Yeah.
away.
Well, you know what I like to do? I like to think about this. I like to think about what was happening on the Earth at the time that this particular galaxy's light left it 24 million years ago.
Wow.
Yeah. Now, if we take these little measurement bars and put them here, the galaxy takes up just about 200 pixels. And what's interesting about that is I know how many pixels across it is, and I know how they translate to degrees. And we actually end up with like it's 0.97 arc seconds per pixel, or a very small number of arc minutes. And so we multiply it by the 203, and that'll tell us how big the galaxy is in size. We have to wait for us to get a photograph of it first. So we're going to do that. I'm going to actually set up a picture now. All right, this is cool. Why am I seeing fuzzy? Let me go look at my AllSky. Make sure we don't have clouds creeping in here. Okay, this is the view. Yeah, see, no clouds. Here's the Milky Way. And we're looking over here. Actually, what we can do is I can show you our homepage view. We're going to make this available on the internet as well. And you can do this. You can show all the constellations, see where you're looking. And we were just looking at Corona Borealis. And if you hover over the objects, okay, then you'll see that we can actually show, like Measure 92 is a globular cluster. So it shows it. Okay, Measure 51, the Whirlpool Galaxy. Here is, this is, I think this is M11 OC. It goes on and on. So you can do all kinds of cool things. But that's really neat. And we're over here now looking in Coma Berenices. And so let's go back now. Let's get out of here and minimize and set up our photo. Let's set up our next stack. This is gonna be cool. We'll do a 25-second shot here. And that's underway. We're gonna go now into deep sky mode. In our deep sky mode, we're already guiding over here, so we're good. And we can clear this out of the way. I'm going to change our camera properties here to make this just a little darker. Here we go. Good. All right, so here it comes, and now you'll see it. This is a really cool galaxy. Look at that.
Wow. And the thing is 20 plus million light years away.
Easily.
Wow.
Yeah. And I'll tell you what a little more detail about it in just a sec. This is the Black Eye Galaxy, so named because it has this extra dark dust lane in it, which is really cool. All right, and let me confirm the distance for you. Yeah, 24 million light years. Actually.
Wow.
Yeah, I like to think about, like I said, what happened on Earth, what was happening on Earth at the time the light left this galaxy. What was going on 24 million years ago? That's when the light you're seeing right this second left that galaxy.
Wow.
That's pretty cool.
It is when you think about it that way.
Yeah. That's right. Thank you, Izabela, for providing the links to the server tonight. That's very kind.
But you can take that same approach to a lot of the activity that goes on in the night sky with supernovas and everything else, like what was going on at the time that happened, looking back at time,
That's right. Yeah, it's a good thing our sun isn't going to ever go supernova, because then we would say, what happened 8 minutes ago? What happened? What was going on? I was talking to Bill about going and streaming 8 minutes ago.
That's a little too close now.
It's a little too close for comfort.
Yeah.
Yeah, so here's the thing. If we zoom in on this galaxy, check it out, okay? All right, the Black Eye Galaxy has this bright nucleus, and then you have this these arms. You can see the spiral arms. I can actually enhance them a little bit. Here, watch. I'm gonna add a mask to sharpen them up. Watch. All right, so this sharpens up these arms. That makes a little more noise, but we can actually work with that, because what I'll do is I will take this mid-range level and slide it down a little to kind of subdue the noise, but show you some of the detail in here. Yeah, so that's pretty cool. Now I can actually see what it wants to do. What does it think it wants to do? And it always tries to do that. Okay.
I can almost see it now, the spiral in there.
Yeah. But I want to also make it clear that if we just bring this here, bring this up just to the peak. Yeah, okay. But you see, there's lots of detail in here.
I see it. That's what I'm saying. I started to see the outline of that.
Yeah, and then I'm going to pull this back down.
Wow.
Now you got some really real detail. Now we've only got 8 stacked here. We get to about 10 or 15 or 20, and you'll start to see a lot more detail, and all this noise is going to kind of go away.
I want to see that.
I know.
We're
impatient. We're impatient. Meanwhile, while we're doing that, over in the other part of the sky, we've been looking. Okay, we find that a lot of the objects that we couldn't see before in the summer sky coming up are getting higher in the sky. And we're going to look at the blue Horsehead here in just a minute after this. And then we're going to try to look at, let's see here.
What are the stack intervals seconds wise right now? What's the?
Right now we're doing
25 seconds.
We're doing 25 seconds on this.
Okay.
Yeah. I'm going to take the enhancement off just to kind of soften that up a little bit. And you can still see it, but we have to let more data come in.
Mm-hmm.
Hope you folks are enjoying this. Please let me know. Please give us a thumbs up. It'd be very helpful.
And definitely check out skytourlive.org.
Oh yeah, skytourlive.org. That's our portal. Now, this is brought to you by our patrons. Okay, the people that have helped us out. So please consider becoming a Patreon member. I think that you would find that what you get for it is actually pretty good. We give you the final processed images at the upper tiers, and it really is amazing to see these. You can enlarge these to put them on a wall if you wanted to. And here's our patron list right now. These are all people that have contributed to us. They're actually really, really dedicated. So
it's amazing when I think about it that we're looking at something 24 million light years, and here with all the haze, I can't even see a star. With all the humidity.
Yeah, it's pretty hot here.
It's pretty brutal.
It was 118 out at the observatory today. Actually, 120.
Wow.
That was outside. And inside was a little warmer because the sun was beating down. Well, actually, it might have been a little cooler because of the shade. But we have a solar fan on the roof of the observatory that turns on when the temperature reaches 120. And I'm suspecting it was running. So look at that. Isn't that something?
Huh?
Yeah, and we're at 14 shots now. Probably 15 now. Yeah, there we are. So I'll save the Black Eye Galaxy. I'm going to call it the Black Eye Galaxy. Yeah, and that helps Izabela because she actually populates our app almost nightly. In fact, I remember we did the Eagle Nebula, which we're going to do later. And when we did the Eagle Nebula, we did it late at night, and by morning for me it was in there. So where she is in Bulgaria, it was already into her day, so maybe that's why she was able to do it. But boy, I'm spoiled waking up and seeing those things done. It's like, wow. She's great. All right, let's try the mask again here. All right, actually what we can actually tone it down too. We can actually drop this down a little bit. The amount. And then the radius. And that'll help reduce some of the noise as well.
How many have been stacked so far?
Over here you can see there's 17 right there.
I see it. Yep.
I don't know if you guys can read what's on the bottom line here. We're going out at high definition 1080p. So there are people that actually put this on their large screen televisions and make popcorn, because we have nice music, we have some nice talk, and we show you cool things. And by the way, you get something for nothing. So it's kind of cool.
But support the Patreon if you can.
I would like that. We really need to do that. Our Patreon support goes toward, for instance, I don't make any money on this, none. I'm not taking any money. I don't make money on this. So what I do is I will take all the money and I put it right back into equipment and getting, like right now, our next step is to build the housing for the Benson telescope. And so we definitely need some donations for that.
And don't you pay for the Starlink connection for this?
We pay for Starlink too. That's $120 a month.
Wow.
110 a month. A month. So $1,200 a year.
What's the speed you get on that Starlink, Mark?
The download speed is pretty high, like 80 or 90, and the upload speed is like it's supposed to be 40, but it's actually only about 18.
Yeah, that's what I figured, like 20.
We're in a low bandwidth area for Starlink, believe it or not, out there, because it's only the middle of the desert.
Yeah, really. It's in the middle of nowhere.
Yeah. So notice now, after 22 exposures, this noise is actually getting softer. And now, at this point, we can...
I'm seeing a secondary ring forming around it. The inner ring, you could see it.
See this now?
Yes.
That's another spiral arm in there.
Yep.
And we drop this down, and it'll even show better. All right, it'll kick in here in a sec. Now you can see the structure of this galaxy and the black eye. Isn't that cool?
It is.
I do not include the audio files in the database, Ray. Kathy, thank you so much for dropping in. It was so nice to see you.
Yes, have a great night, Kathy.
Yeah, so this is good. All right. We'll save this here, Black Eye Galaxy, and save it exactly as seen. All right, now let's go back to our system here, and I want to see now.
The horse?
Yeah, I'm going to go to the dark, not dark, we're going to go to the blue Horsehead right here.
Yep.
Now, we've looked at this before, but I'm going to look at it again. And first thing I'm going to do is get out of the stack and stop stacking. Actually, I'm going to save it with 25. That's a good thing to do. Nice round number. Okay, good. So now we can get out of this and go into our low light mode once again. And now change our magnification back to 25%. There we go. And now we come back to our planetarium program and head on over to the blue Horsehead. Now the blue Horsehead is punctuated by these two bright stars known as Jabba. Like
there we go.
Jabba the Hutt. Yep, there it goes. You see the telescope is now going to head toward the south, and just a little to the east, to the west of the meridian. Okay, and there's
I love that feature. I love it.
There's Jabba right there.
Seeing the telescope move, I love that.
Isn't that cool?
It really is.
Yeah, it freaks you out when you say, "Why is it moving?" You know. So what I'm going to do now is I'm going to come down here. I'm doing an ongoing mosaic. I did this upper part. I did the lower left part, and I'm going to do the lower right part. Okay, so I'm going to do this. And I'm going to be moving it over. There we go. This is the kind of music I'll play on my blues guitar, my electric guitar.
Do you have music playing right now in the background?
I do. You can't hear it because it's
Yeah, I can't. Yeah.
it's on the stream.
Yeah.
I think people hear it. All right. Yeah, I love improvising with blues tracks and stuff. It's a lot of fun.
Cognitive in Rumble, he's moving the telescope right now to a new location. It takes a few minutes to settle into the spot and get the adjustments going, and you'll see it shortly.
Oh yeah, it's almost there. I'm just moving this.
Stacks are happening.
It's moving up a little bit, right there, and this is where it's going to stay. So now we're locked in, and it's searching for the guide stars, and we can start thinking about going and setting up our exposure. This is going to be a 35-second exposure. All right.
Why so much?
Because at this point, this is a faint nebula here, and I would like to show the nebula, and so I'm going to do that. So I go into the live stack. We'll have the Black Eye Galaxy in there from the last time, and you can see with all the stuff here, you can see all the satellites that came through that you didn't really see. That's ultra bright, but that's because this is also going. And now we have 10 seconds left on this first exposure of the Blue Horsehead Nebula. Why is it called the Blue Horsehead? Well, because we're looking at what happens when ionized carbon monoxide scatters the blue light from the stars. All right, so there is the blue. You can just barely see it here in this first exposure. And it's a lot down here. Yeah, see all that?
I see it.
Yeah. So I'm going to color correct, and that'll actually make the colors a little more visible. Okay. The halos are around bright stars because we have a telescope that is running 25 times faster than this telescope was natively when we got it. So we modified it to run that much faster. And that speed is meaning that we went from like an f10 telescope, from a photographic f10 down to an f1.8.
Wow.
So it's 25 times faster photographically.
Wow. It's almost like a camera lens.
Yeah,
Like
in fact it is.
Yeah, it's like a Sony. Yeah.
And actually, if we go to our stellarium image just for a minute, okay, I want to show you a little bit about this, because this red box you're seeing here, that red box is the size of our field. So it's 1 degree, 29.25 minutes, so almost 1.5 degrees across, and almost 1 minute tall. 1 degree tall. So that means 1.5 degrees is 3 full moons across and 2 full moons tall.
Interesting.
That's how big. So when you see the moon in the sky, just figure 3 full moons side by side and 2 full moons stacked is the size of the field we're looking at in the sky.
Huh.
Isn't it crazy?
It is.
Yeah. All right, so I'm there, so I need to...
Mark, what causes the blue? What kind of gas is that due to? What is creating that?
Yeah, that... Okay, this is dust, okay? And this dust has liberal amounts of carbon in it, and there's one compound. There's a gas called carbon monoxide, okay? And ionized carbon monoxide, all right, will be on dust grains as well, and the dust grains will very, very nicely scatter the blue light from stars like JWST. And so when you look here and we zoom out a little bit, you can see that JWST has had that that light scattered. Let me try and bring it in. Now you can see it much better.
Question from Cognitive Nomad: is this a refractor telescope or a diode direct?
It's actually a Schmidt-Cassegrain telescope that we've modified. So it's not a refractor, it's a Schmidt-Cassegrain. The difference between Schmidt-Cassegrain, there you can see the blue much easier now.
Yes, definitely.
And it's here too. Yeah.
How far, Mark, is this?
Distance, I'll tell you in just a minute. Let me raise the bar here. Okay. Distance to the blue Horsehead, it's kind of dust that's in our galaxy and our kind of in our galactic plane, and it's 521 light years to this dust cloud.
Wow.
Yeah. Now the Pleiades are only 400 light years away, and they're also surrounded by a dust that's scattering their blue light, and it's possible that we are in the Pleiades dust cloud, which is kind of an interesting development. Yeah. Catherine says, good choice of music. Thank you, Catherine. Jessica's with us. Hi, Jessica. Didn't see you come in. I'm glad you did.
If the Webb was looking toward Earth, or not even toward Earth, or to the side more, would it be able to pick that up?
May I say that again?
If the Webb was turned toward us, our planet, but not directly because it would probably be overwhelmed by the lighting, could that at some point see the dust near us? Or is it near?
Yeah, see, they would maybe, but they would never point the Webb at us. The problem is that the Webb is a extremely sensitive instrument, and literally pointing it at us could damage its sensors.
Right. That's what I figured that was the light.
It can't ever be pointed anywhere remotely near the sun.
Mm-hmm.
All right, so I'm gonna do a push. When you move these two lines closer to each other, you're pushing, and now you can see even more detail in here. This is all blue nebula. See it, guys?
I see it.
Really cool. Wow. And so I can just bring this up just a little bit more to the peak. You don't want to start going beyond the peak with this black level, because then watch what happens. It starts eating away at your data.
Wow.
See, and you don't want that.
So there's only one stack on this so far?
No, there's 7 have stacked.
Oh, I can't see it.
Yeah,
Okay.
it's right here.
Yeah, I'm looking. It's hard to see it. Okay.
Yeah. 7 stacked with 3 rejected because, of course, I had my threshold for roundness of the stars too low, and I don't want any stars to be elongated and ruined, those, so I don't do it.
That looks beautiful.
Oh, it's going to be a beautiful image. Yeah. And what we could do, you know...
How many stacks would you do for this? 15? 20?
I might probably do 15. You know, first thing I'll do is I'll just move this out of the way, and then I'll get rid of this. So we'll put that down as well, and then we'll increase the size so we can fill the screen with this.
Oh my gosh.
So it makes it a little easier. I'm out in space.
That is a beautiful image.
The atmosphere. Yeah.
I can imagine what that's going to look like with 15.
It's going to have less noise. Now, the other night, I actually went to 79 or 80 images for the Pillars of Creation, and it looks beautiful, and the Lagoon Nebula too, and it looks just outstanding. It looks so stunning. You could zoom in on it so much better.
Wow.
Yeah. Right, so let me and so we still have good focus here, and you can see there's blue here, there's blue here. This little glow you're seeing, it always looks like there's a bright star just out of the view. That's actually amplifier noise from the system. But the nice thing is we can remove that. And right now we're applying a flat field correction. What happens is when you take pictures with these sensors, the center ends up getting bright and the outside edges get darkened. So you have that weird change. So what I've done is I've kind of added a opposite corrector that makes this a little darker in the middle, a little lighter on the outside. It's called a flat field correction. I did that when I was out there. I actually created a flat field files when I was actually in the observatory working on it. So I just pick a flat field and correct with it because it just corrects for the sensors the way they naturally work. I also have a dark frame that I'm subtracting so that we get rid of a lot of the extraneous noise as we go. So it's pretty cool. Yep. Izabela says she's thinking of getting a third monitor, but then she might turn into a zombie.
I got 4. I know the feeling.
Yeah. My son he had 2 and then another 2 up above. I mean,
Yep.
It's like he was encased in monitors.
Mm-hmm. I know the feeling.
Yeah. But the thing is, if you saw him working, you'd say, he's using all those monitors. How in the heck? He's only got 2 eyes. Actually, the monitor I'm using is one of his old ones. It's a big curved monitor. Okay, so the center is the furthest away from me, and the edges are a little closer because the monitor curves around. So you'll see me looking here, right, this way. I'm looking right now on the broadcast screen. It has my picture on it, labeling, titling, and stuff. And this screen here is the live feed from the observatory. That's actually the feed that Bill Skywatcher is looking at because that's the one I'm sharing with him.
Exactly.
Yeah. Now, I could change that on him and quit sharing like I just did.
No!
And start sharing this one. And now he'll see everything.
Oh, yeah. I see your stream.
Right. And now he sees the whole broadcast screen and stuff.
He's OBS.
Yes,
Streamline.
that's right. But that's not what he wants to see.
No. No offense to everybody that's in the chat. I just wanted to see what he was sharing.
He wants to see this screen, which is the bigger,
Yes.
which is the actual raw data screen from the observatory. So he sees just the data and the camera that we're looking at. This part of it. Okay, he doesn't see the rest of the video. He doesn't see the labeling down here. He doesn't see anything else. He just sees this stuff. Okay, we've got 11.
I got my screen sharing on monitor 1. I'm looking at your sky blown up in full in the middle.
Okay.
On third screen, I got my OBS, and on my fourth screen, I got all my pop-out chats.
Okay.
So,
Now,
yes, 4 screens do come in handy.
Yeah, now here's what this is doing, this full width half maximum filter. It's actually making sure the stars stay small enough to within the threshold that I define. We had one come in at 10, over 10. And what is that? Well, what that is it means that there was some wind and it blew the telescope around. Because if you notice, the telescope's sticking up. Well, you can't see it right now. And it's blowing in the wind. So that particular frame, followed by the next 4, were affected by wind. So those frames are being thrown out because we don't want wind affecting our frames. We want perfect photos, so as long as you're willing to wait, you'll see the actual frames so that are perfect. You won't get the bad frames.
Yeah.
So let's see what this next one, 1 second to go. Let's see if this next one comes in. It did. It did. See, the wind died down. What's that?
It still looks stunning regardless.
Oh, it does. Yeah, so that's 12 shots. So I'm going to change the name. We're going to call it the Blue Horsehead. And that's going to be an emission nebula. I'm sorry, a reflection nebula, RN. Reflected light, meaning the scattered light is blue. All right.
Do we have one more target before the night?
Yeah,
So-
we do. That's what I've been waiting for. All right. Okay, so what I'm going to do now is bring back the telescope, my gesture. Okay. And there it is. And now, let's go over to our histogram, do a final little push on it to see if we can get a little more data out of it. Oh yeah, look at that. Gorgeous. There's a lot of nebula there, guys. That's going to come out pretty. All right. So we'll save it one more time. Oh, I already am waiting for the exposure here. I already saved it. Okay. So we can get out of it now because we saved it already. And go into our low light mode again. All right. Low light mode coming up. And we go over here.
Sean says dark.
It was a satellite. That's not Starlink. That's a different satellite. Why is it a dash? Because it's a 1 second photo. So it's doing a time exposure, so it drags it out a little bit. And notice it's going to the east. Left is east, right is west. Most satellites go to the east. All right, let's go over here now. Well, first of all, let's come back here. Let's bring Java back down in here. And oh, that boot is so low.
I was just thinking of that. I'm not even kidding. I was here at Jabba the Hutt. I was like, what's going on?
Yeah.
Who comes up with these names?
I don't know.
You know what I mean? Like,
Yeah. Well, you know, there's creative people.
yeah.
You know, probably lots of drugs involved. You know,
Guys.
I know someone that worked at Industrial Light and Magic, and man, the stories he would tell me. Okay, we're gonna let this come in here, and when it finally positions, I'm gonna now go in here and see how far off we are from Java.
On a side note, if you live on the coastal areas of Texas, please monitor your weather within the next 48 to 72 hours.
Is that barrel?
Yeah.
Yeah. All right, there we go. We are now synced up, and so what I'll do now is come in here and get rid of the crosshairs. Okay, and now I can come back here and go now and try to take on. Oh, this is so beautiful up here. I mean, I'm dying to do it, but there's a beautiful dust cloud near Antares. You know the eye of the scorpion, the heart of the scorpion. And I'm gonna not do it because I'd rather see if we can grab our beautiful. Let me get down here. There's Antares. Dark Horse we did. I'm going to try this again. Okay, this might work now. We're going to try the Trifid Nebula. We tried it the other night, and it wouldn't guide for some reason. I don't know why. But the Trifid should be visible without any interference from the building right now. Yeah, there it is. You want to see a beautiful nebula? Oh, you have seen nothing yet. Okay. So here we are, and I'm going to...
What's this one called, Mark? Again?
Trifid. People call it the Trifid sometimes. It's a...
Yeah, they had the Trifids.
Remember? Yeah. Yeah.
That's what I thought of immediately when you said it.
Yeah, Day of the Trifids, yeah. And how did they kill anybody? That they were just like plants.
Yeah.
Just annoying.
I mean, Venus flytrap in a big size might be interesting, but
Yeah, actually. That's a good one.
I don't know about Trifids.
Yeah. Okay, this nebula is a really cool one because it portrays a couple of different nebula. The red one you can see, this is ionized hydrogen gas, okay? Then you can see a blue one up here. So it's made in the same way that the other one was. It has this incredible dust in there, and that dust is actually very much sensitive to high frequency light. We're going to do a 20-second shot here. All right. And that sensitivity, we're going to go into deep sky mode now. That sensitivity is very interesting because it means that the dust can scatter. That's the remains of our other one. The dust can scatter the blue light and make blue light appear around this nebula. In fact, there's a whole shroud of blue around the pink nebula, as you'll see right now. Look at that.
Wow.
And we're going to color correct, and you're going to see all kinds of other red emission nebula all around it. As we zoom out, I'm going to move this out. Okay, just past the peak here, and you can see even more show up. There you go. And now I'm going to drop this down. Isn't that pretty?
That is amazing.
Yeah, let's zoom out. Look at that. Look at that. Isn't that beautiful?
It is stunning.
Yeah.
Somebody said in my chat, wow, in caps.
Yeah. That's pretty.
It is a wow.
It is definitely a wow object.
And by the way, happy birthday, Sean, on Monday. And hello to Starseed.
Oh, Starseed's with us.
Mm-hmm.
Hello, Starseed. And hi, Prow. I see you there, along with Mr. Django. Mr. Django is in Belgium. That's Steven.
Cool.
Steven is a astrophotographer himself. Hey,
Please.
look at Marianne Robb is with us.
Hey, Marianne.
That's Bill you're hearing, of course, Marianne.
Oh, she knows that.
Oh, yes, she does. That's right.
Marianne, I've lost 50 pounds since you seen me last time. That's accurate. 48 to be exact.
Yeah.
Now I'm doing biking like 10 miles every 5 days a week. 50 miles a week so far.
That's crazy.
Yeah. And I'm going to do a lot more.
All right, we're going to save this.
Enough of that talk.
No. Nothing wrong with that.
No?
Very cool.
That is beautiful. And again, these are available at skytourlive.org.
Yeah.
And what's the Patreon, Mark? Again, please? What is it?
Yeah, the Patreon is Patreon.
Is there a link on the start?
Yes, if you go to skytourlive.org, the Patreon is to the upper right. You'll see the Patreon at the upper right, and you'll see the SkyTour live stream on the upper left. So you look on the screen, just take a time to look at the screen, you'll see where everything is. Yeah. Marianne said hi to you.
And definitely high back.
Mm-hmm.
Now the thing is, Mark, if you were in that nebula, would you actually see the reds and the blues, or no?
You might see a subtle red surrounding you, because remember, that's several light years across.
Right.
Okay, so
that's
we're talking, for the few thousand light years away this is, we're talking about something that is, going to definitely be permeating this region of space around you.
So if you were on a planet that was inside this, their sky would have a reddish hue to it at night?
Possibly.
Okay.
Yeah, because when you're within it, it may not look that way,
Right. That's why I asked. Yeah, I get it. From a distance, you can see it like this.
That's right.
Still amazing.
Right. I'm trying to balance my values here to see if I can get this to stack right.
I'm going to ask this stupid question. You ready?
Yeah, go be stupid.
What is from one point of the Milky Way to the opposite end? How many light years does that span?
100,000.
Wow.
100,000. Now, what's interesting is when you look at all these stars you see in this view, every one of these stars you're seeing in this view are at all different distances from us.
Right.
So you're looking at them as they were, and when you look, say, here, you're seeing them one time, look here, and you're seeing them at another time. You're not seeing the universe as it is now at any point.
Mm-hmm. You're looking into the past.
Yeah, you are indeed looking into the past. All right, let's try this one more time.
That's amazing. And I'm sure it varies, but between galaxies, that's got to be a lot of light years in between.
Yeah, I mean, if you go there, it looks like they're all clustered together. But from there, it looks that way with us, too. But when you see that, it's 4 light years to the nearest star, even in a globular cluster, the stars are several light years apart from each other, But it just don't notice. You don't really know what that means. All right, we're going to save this. I want to get onto another object if we can. All right. This one refuses to stack. I don't know why. I'm doing everything right. All right, here we go. I'll discover why, because it used to stack just fine. Okay. All right, so now let's pull out of that. And now we're going to be able to do this other one that we're looking at. And I know we will. Okay, this is what we're going to do here. I want to get to... here's one we haven't done... Here's what we have not done in a year. And this is one we haven't done ever with this camera. This camera was installed just last November or so. And so we didn't have a chance to see it in the summer sky, so now we are. All right, this is called the Omega Nebula. And this is pretty cool. All right, so I'm going to just bring it down. It's actually pretty close. Okay. We'll set up an exposure. We're going to do 20 seconds. Okay, it's searching, finding our guide stars. We'll get out of low light mode and go into our live stack. You'll see the Trifid Nebula. I'll figure out why it's not stacking and fix that and get that one to work again. It's very weird. Okay. But here you're going to see the Omega Nebula. And the Omega Nebula is a fascinating nebula. It's a stellar nursery. And there's some star formation still going on. But look at that.
Wow.
That's just gorgeous. Now this
What's going on the right side there?
There?
It seems there's two pillars there. Yeah, there.
Yeah, that's actually dark nebula that's in front of the bright nebula behind.
Wow.
Let's see if this one's going to stack right. Nope. Why is this one not stacking right either? What changed? What changed? And
Are those colors accurate that we're seeing?
Yeah.
The red off to the side too, as well.
yeah, let's actually color correct so we can get these aligned. All right, here's the correct colors right now. They're right there.
Wow.
Yeah,
There's even blue in there.
that's correct. There's a little bit of a reflection nebula. There's dust in there as well. This black stuff is the same dust. It's just that here it's actually scattering starlight, and here it's in front of you. It's in front of the bright nebula, so it looks dark.
Dense? Is it a dense?
Yeah,
Is the density of it?
yeah, it's denser. Yep, it's definitely denser.
Incredible. Do you ever think, Mark, what it looks like now?
I do. I wonder what it looks like.
Because we're looking back in time, I can only imagine. You can only imagine what it looks like now.
I know. I agree. Let's try this.
So, how far do you know? Well, I want to know the distance, because would it change dramatically? I mean, it takes millions of years to see anything really change in something like this, right? Or, like, if you looked at this 10,000 years from now, would it?
With 10,000 years, you might have some very subtle differences, but
That's what I mean.
it depends how far away it is. I mean, this is.
That's exactly why I said
Yeah, the farther away it is, the less you'll notice things.
this. So it probably hasn't changed much.
Oh, no, probably not. I'm trying to figure out, again, why these with these nebulae, it doesn't seem to stack. It's always stacked. I don't get it.
As it happened with the last one too.
Yeah, I don't get why he's doing that. Let's turn off this guy. Shouldn't matter, but I want to just tone down some of the noise.
Yeah, that looks nice.
Isn't that pretty?
It is.
It
He says
is
it's
beautiful.
5,000 to 6,000 light years away from Earth. That's what somebody in my chat just said.
Okay, probably true. All right, now we'll go again.
Doesn't sound like much, but it is.
Yeah, it is.
Gosh.
That's really pretty.
That's like in Mary Ann's house with the gallery of the images.
That's right. And the Sky Tour home base.
Can you? And I've seen it in person. So, can you imagine, folks out there watching this right now, if you had a bunch of these framed in a room, living room, dining room, any room? I'm telling you, it is your eyes just automatically go to those images in that room. I'm telling you, it's just stands out. It's stunning. It's amazing.
It's really pretty.
It really is.
Yeah, and again, when our app is available, you'll be able to view images from all the way back to 2021.
Wow.
And Ronald's with us. Hey, Ronald. That's Earth Radio. If you have a chance, go check him out. Earth Radio.
All right.
That's right. Ronald looks like Robin Williams. Yep. Okay, let's see here. Look at all detail in there. That's crazy.
That's amazing. And that's not even stacking yet, right?
Yeah, it's just for some reason we're not stacked, but it's still pretty.
It is. That's what I mean. Just from that one, it's still amazing.
Yeah.
Now, something like this, what is it? Is it an average of 15 to 20 stacks to get like the image you're looking for?
Yeah, 15 to 20. Yeah, 15, 20. Yeah.
It's still one, and look how beautiful it looks. It's unbelievable, to be honest. It really is.
Oh yeah, it's really pretty. Let's see what the log
Mark,
say.
it almost looks like the other side. This is a pareidolia thing going on, but it almost looks like the right side was at one time closer together to the midsection, because you see how it sticks out where the white is and the density there, right there. But if you look, it's almost like that shape would fit into the other side. Like that would be. It looks like at one
here.
Okay, you see what you're pointing at right now?
Yes.
Now go to your right. Go
My
right. Go to your right.
That is my right.
Well, then I'm looking at the opposite way. That way. It almost looks like that piece would have fit right in there. In that, yes, like it would have fit.
Like right here.
Shit, I wish I could do it. I could say it, but it almost looks like the section on the right would have been closer together to the midsection. It looks like it broke off.
But what's funny is that's an illusion, because what you're seeing is dark nebula in here. That's leaking into this. This comes from here. This is all dark dust in here, blocking the nebula behind it.
Ah.
See? So this is a wide set of tendrils that are sticking out.
Ah.
Okay. Yeah.
So it's being blocked.
Oh, yeah.
Wow.
Exactly.
That just blew my mind.
Well, it's a different way to think about it.
It is. It just totally.
All right, let's try. I saved this, I think, didn't I? If I hit save, we see a red box. Yeah, I already did.
Yeah, look, frames rejected 10. Oh, is that a 10 or
11? Yeah, I'll figure it out. I'm going to talk to Robin, who's the author, and figure this out. All right, we're going to go here.
It is trying to stack, but it's rejecting them.
Yeah, but if you notice, for some it didn't. So I'm trying to figure out why it didn't. It's not the camera. It's this application. Something with this is causing it to do that. It's probably because it's a very, very galactically rich area.
So while he's doing that, for those that are watching on my stream, and we're sharing his stream, if you go to Sky Tour live stream on YouTube, subscribe, hit the notification button. On Twitch, it's STLSW. On Rumble, I'm pretty sure he has it as Sky Tour live stream.
I should.
And just go check out skytourlive.org. Everything is the hub. So pretty much, if you go to that page, you can connect to pretty much everything from there.
Yeah, that's our portal. Skytourlive.org right there. That's our portal.
Exactly.
And you can check everything out you want. All right, so now...
And I will all let you know when the app is available in the near-term future, so that you can check it out that way as well.
Yeah. All right, so this is our last image for tonight, but it's worth waiting for. It's the Pillars of Creation. When the Hubble did this, it was stunning, and when the James Webb did this, it was even more stunning.
Yep.
And so that's the Omega Nebula, and we're going to clear that because we saved one frame of it. And we're now going to do this guy. So check this out. First of all, we're going to color correct. And now watch. And boom. And this is actually 1 second. It's got 3 stacked. I'm going to actually do it for 10 seconds. It doesn't need any more than that. Alright, so we're going to do 10-second stacks here. I'm going to clear this. And watch. We were doing 25, 35. Look at this. Beautiful. Now, it doesn't look like much yet. But wait until we do this. And move this up the curve. There's the pillars of creation. You see them, guys?
Oh, yeah.
So this is what the Hubble focused on, was right here in this box. Okay. Beautiful. So we can zoom in on that. Look at that. Now see, we got 5 stacked already with no problem.
Yep.
So something's...
Wow.
Look at that beautiful stack. Look at this.
My head just stood up for that.
Yeah, this is... mostly...
Can we spend more?
Huh?
Oh, yeah, you were doing it as I was saying it.
Oh, okay.
Zoom in. You read my mind.
Yeah, so I'm gonna darken this up a little more now. Add the contrast. Look at that. And then let me add the enhancement back to help light these up. Check this out. Now you can see how sharp and clear these are. Is that something else?
Amazing. I'm like sitting up to watch the screen.
Yeah. Well, what I'll do is I will do what I did before. I will gesture and move that off. And then I will drop this down and allow this to take center stage. Now you can see this dark nebula up here. This is all dark nebula up here. All of it. And so some of the dark nebula bleeds into this nebula that's lit up, because what's happened is there's a hot cluster of young stars here. And these young stars form a cavity around themselves. Right? So for those watching, I'll move myself out. Here's the pillars. Here's the cluster of stars. Now, this cluster of stars that you're looking at right here they have very hot radiation, ultraviolet radiation, and it's blowing a bright, hot solar wind down at this area. All right, and in this area, one of the things that's happening, if we zoom in some more. Okay,
yes, please.
All right, if we zoom in here, okay, if you look, these pillars, this area of the pillar right here is actually dense, pretty dense. Okay, this area of this pillar is very dense. The same thing here. So the starlight is striking this area of the pillar right here and can't erode it. So it's protecting, this pillar is actually protecting what's behind it. Okay, same thing here. This pillar is protecting what's behind it. So it's coming down here. The starlight is trying to get through here, but it's pushing gas and dust away from the sides because it doesn't have a dense area up here like this to protect it. So that makes a stalk, or a pillar as we call it. Same thing down here. This little pillar went to market. This little pillar is pretty dense here, and the starlight is eroding away around it, but it can't erode what's directly behind it. So you'd be right to think that these pillars point exactly toward this star cluster, and they do. So they're pointing exactly toward the star cluster. And that's where these come from.
Do we see similarities in other areas of the sky with the situation, Mark, or is it unique to this area?
These pillars are quite common, actually, and they're formed the same way.
Mm-hmm.
Yep. They're all formed the same way from this very, very bright starlight. You can see it really clearly now. This cluster is blowing in this direction, and this whole area has been carved out by these hot young stars. Okay? And they're responsible for shaping what's going on inside this area. Where it's dense, it can't erode it away. Where it's lighter, it can. Look how far out it pushed it. And it's still pushing, so it can be pushing away. But here it's actually doing this. It's coming up against these hardened areas that are more dense. So what could be happening here? What might be going on inside here is that there could be another star system forming in here. Same thing here and same thing here. Maybe someday planets could be forming in there as well. So it's pretty cool.
It is.
Yeah.
Amazing. Stunning, actually.
It is.
Even when
very
you zoom
pretty.
out, the beauty of the entire nebula it's just stunning.
Well, when I zoom out, I want to show you, we're looking at many light years here, okay, across. And this star cluster is hot enough to ionize hydrogen gas light years away.
Wow.
See? It's energetic enough, we should say. And so, even though the intensity of the radiation falls off as the square of the distance, so when you get 2 times further away, the radiation is 4 times less intense. If you go 4 times further away, that's 16 times less intense. And still, it's doing this all the way out here.
I'm going to ask another stupid question. Could that almost be common, similar, let's just say, to a global cluster happening within this nebula, with these young stars being born? The density of these young stars.
No, because the globular clusters are much further away. So if this cluster was much further away, then it would look like a compact cluster. But this cluster has maybe 100 stars, maybe more. I gotta find out here if it tells me how many.
Because it looks like there's quite a bit in that center area that you're pointing to right now.
Yeah, and this right here has a lot of stars. But keep in mind, globular clusters can have up to 500,000 stars.
Yeah.
Or more. So we're talking lots and lots of stars compared to this is called an open cluster if this was all alone. And over time what's happening is these stars are pushing away all this gas and dust, and eventually that gas and dust will be far enough away that it won't the stars won't ionize the gas anymore.
Mm-hmm.
And so therefore these tendrils you can see will be dark again and blend into the background. You won't see them anymore. And we've stacked 40 shots already.
Wow.
Yeah, these are only 10-second shots. So I'll change the name here.
Wow.
It's called Messier 16, the Eagle Nebula. It's an EN, Mission Nebula. Okay. And we'll bring this up to save. And save exactly as seen. Okay. Now what I want to do is I'm going to just do a test. I'm going to do a 25-second exposure. See if we can get it. This tells me whether I'm going to need to worry about that.
Mm-hmm. Because you didn't have an issue just now.
I was doing a 10-second exposure.
I know, but that's what I mean. You didn't have an issue stacking.
Yeah. I said 25 seconds.
Mm-hmm.
So I'm going to do 25 seconds. All right. So now it's doing a 25-second exposure. This has been saved. We'll dock this back up for the time being. We'll clear this. Now we're in deep sky mode, and we were in deep sky mode just before. All right, and now this will look similar, but it'll have a little noise in it. Okay. All right, well, at least it's consistent, so it didn't do this second one.
So it seems that 25-second one is the issue.
Yeah, I don't know why it's doing that. But we'll wait and see. Michael Hedrick's asking you if you think we'll see a telescope on the moon within 10 years.
I don't know about 10 years, but I think eventually.
Yeah, the moon's actually not the best place for a telescope.
Really? But because there's a lack of an atmosphere there, wouldn't that help?
Yeah, sure, but an orbiting platform can do the same.
True.
And on the moon, you've got this dust, which is going to get all over everything.
Yep.
Yeah. So it's like glass, so it'll cut into instruments and everything. Okay, so this isn't working with this either, so I'll have to figure that out with Robin, have him talk to me about it. Bring my telescope back here. And
this has been awesome.
Yeah, it's been a great time.
Yes.
I hope you guys had a good time. I did. All right.
We definitely did.
Right.
Please let me know if you invite me again.
Oh yeah, I will. I'm going to close up now, so what you might as well see that too. Why not? So let's do this. Let's actually bring out our telescope view a little bigger. Didn't want that.
This is cool.
Yeah, it's neat to see because it's fun.
Yeah.
Let's bring this guy up, and let's go and bring him up.
From thousands of miles away, remote.
Yeah. All right, so what I'm going to do now is I'm going to park the telescope, and that means it's going to go to its predetermined rest location, which is going to do... There it goes. And I got this up here. This up here. All right. So you can see it says slewing. Then it's going to say you can turn power off. There we go. And now I'm going to shut off power. This is a program I wrote to access all the stuff in the observatory. Okay, there we go. Power's now off out there. And now I'm going to close the roof. And here goes the roof. There we go. This is the image in the buffer. That's why it's not going away.
There it goes.
Yep. We are done.
That is so cool. That is so cool.
Well, guys, I hope you appreciated this.
Yes.
RJPX, how you doing? Yeah, the spider web never went away. I mean, it actually helps me figure out what the wind is. We'll get a weather station. That's on the schedule to get a weather station and put it out at the building so we can actually look at it online, maybe display it on the screen. And that's kind of cool. But there we go. So now we're all closed up. We can disconnect the scope. And you can hear her say, telescope disconnected, when it finally goes out. She just said it. And now we can quit that. And there we go. All right, we're closed up for the night. Let's take one more look at the night sky, AllSky cam. There it is. That movement you just saw, that's how much it moved since the last time we looked at it. Our constellations are here. We're going to be looking in Cygnus up here soon. Okay. And Cygnus is just a wonderful constellation.
The Milky Way.
Oh, yes. Yep. Milky Way is beautiful. And this is a color camera, so we get to see it, everything in color. Nice. All right. Well,
All right.
guys, thank you so
Thank you,
much.
Mark.
Thank you, Bill. It was great having you on with us. Thank you so much. And we will talk to everybody a little bit later. I hope you guys have a good evening.
Yes.
All right. All right, so say goodnight, Bill.
Good night, everybody. Have a great weekend.
All right, everybody. You have a good night. We'll see you later. Okay, folks. Signing off. Sayonara. Till next time.